In this video, we are going to work through an example of how to calculate net torque. So let's go ahead and jump right into this example. It says, find the net torque about the pivot. So we have some beam here. It's connected to some pivot, and we can see that there are 1, 2, 3 total forces that are being applied on this beam. And our question is, what is the net torque? So for each of these 3 forces, there will be a torque associated with it. So to find the net torque, here's what we can do. The net torque is simply going to be the first torque plus the second torque plus the third torque. Now, how do we calculate torque? Well, torque is simply the force that's being applied multiplied by L, where L is the distance between the axis of rotation and where the force is actually being applied. And then we multiply that by the sine of the angle that the force is being applied at. Now, it's also worth noting that if a force is pushing in a counterclockwise direction, so this direction right here, in physics we typically say that's a positive torque. And if it's pushing in a clockwise direction, so in this direction, we call that a negative torque. So we need to keep that in mind. So let's go ahead and calculate all 3 of these individual torques, and then we'll be able to calculate the net torque. So for torque 1, that's going to be force 1. So this force 1 is 50 newtons, and it's being applied 1.2 meters away from this axis of rotation, or this pivot right here. So we'll say that's equal to 50 times 1.2, and we can see that the force is being applied at a 90-degree angle. So we'll have the sine of 90 degrees. Now, the sine of 90 degrees, that turns out to just be 1. So really what we have is 50 times 1.2, and that turns out to be 60. And our units will be Newton meters. So that's the first torque. And remember, we said that if we're going in a clockwise direction, which this force is pushing it clockwise, we said that's going to be negative torque. So let's write a little negative in front of it, negative 60. Okay, now let's move on to torque 2. So to calculate the second torque, we'll take force 2, which is 40. We'll multiply that by the distance that it's being applied from the axis of rotation, which we're told is 2.5 meters. And then we'll multiply it by the sine of the angle that it's being applied at. So we're told that the angle between the force and the beam is 30 degrees. So we multiply it by the sine of 30 degrees. Now, the sine of 30 degrees, that turns out to be 1/2. So what we get is 1/2 times 40, that's 20. And 20 times 2.5, that turns out to be 50. And again, we'll say Newton meters. Now, this force is being applied in a counterclockwise direction, so we'll keep it as a positive value. And lastly, let's calculate torque 3. So that will be force 3, which we're told is 35 newtons, times its distance from the axis of rotation, which is 4 meters, times its angle that it's being applied at. So this force is also being applied at a 90-degree angle. So we also have the sine of 90 degrees. And again, the sine of 90 degrees is just 1. So we have 35 times 4. That turns out to be 140. And we'll say Newton meters. And this force is also being applied in a counterclockwise direction. So that will be a positive torque. So our final net torque is simply going to be these 3 values added together. So we get negative 60 plus 50 plus 140. And that turns out to be 130. And we'll say Newton meters. So that will be our final answer for this one. That is the net torque about this pivot.